Hi everyone, welcome back once again. Today we're going to focus on question 9 from your grade 12 November 2021 past paper, and we're going to look closely at calculus derivatives. Question 9.1, it says determine f prime x from first principle if it's given that f of x equals to 2x squared minus 3x. Okay, so how do we find the derivative using first principle? There's a formula that says f prime of x from first principle is equals to limit when h approaches 0 f of x plus h minus f of x all divided by what? By h. Okay, so we can simply simplify this by actually going to calculate f of x plus h, right? So f of x plus h, where there is x, we are going to add h, right? Because it's a f of x plus h, so it will be 2. Here there is x, so it's gonna be x plus h, but our x was squared, right? Minus 3 into where there is x, we put x plus h. We can actually simplify this. It's going to be 2. If you expand that to be x squared plus 2xh plus what? Plus h squared minus 3x minus 3h. Okay, so if you remove the brackets by multiplying by minus 3. All right, so this will be 2x squared plus 4xh plus 2h squared minus 3x minus 3h. All right, let me just write this properly. Where's minus 3h here? It's there. All right, so we have actually simplified that. Is there any like term? There's no like term, so we can just leave it like that. All right, now let's go and write what is our f of x. We are given our f of x is 2x squared minus 3x. Okay, so what we can simply do, we can simply come here and substitute on our formula. Limit when h approaches 0. What is f of x plus h? It is actually 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus. Okay, so after writing this minus from the formula, very important, whatever you write that follows, put it in brackets, right, so that you can avoid making mistakes. So you say minus 2x squared minus 3x, because we are subtracting f of x, which is what? 2x squared minus 3x, all divided by what? By h. Okay, so we can now go and remove the brackets by what? By our negative, right? So when you remove by negative, you'll get it as minus 2x squared plus 3x, because it will be negative and this one, and negative and that one, so it will be positive that one, right? Plus 3x. Okay, let's group the like term. Let's add the like terms. So you have minus 3x plus 3x, they will cancel out each other. 2x squared minus 2x squared, they will also cancel out each other. Then we're left with f prime of x is equals to limit when h approaches 0, 4xh plus 2h squared minus 3h. All right, all divided by what? By h. Okay, so we can actually take a common factor of h on our denominator. We can see there's a common factor, right? So if I take out h as the common factor, so it will be like I'm dividing by h there, so we'll be left with something like that, right? So because it was 4xh, as you can see, and 2h squared, when you remove by h, you will still get the same thing we got there, right? So h and h will cancel out each other. Will be left with limit, f prime of x equals to limit h approaches 0, 4x plus 2h minus 3. Okay, now we can now go and substitute that 0. Then our f prime of x will be 4x plus 2 into 0 minus 3. So when you substitute 0, you no longer write limit when h approaches 0, because h now has already approached 0. You have substituted 0, right? So it will be what? It will be 4x. 2 times 0 is 0, minus 3, it will be minus 3. So that will be our what? Our f prime of x using first principle. All right. 9.2.1, it says determine dy over dx if y is equals to 4x exponent 5 minus 6x exponent 4 plus 3x. Okay, so be very careful with the symbol that they use here, especially in your final examination. They can try to trick you, right? Sometimes they can say determine dx over dy, right? So if they say dx over dy, we must first make sure that our equation is in the form of x equals to something in terms of y. Then we are going to derivate x, this equation of x, in terms of y. All right, let me just give you a quick example. They can give you maybe you have something like y is equals to x squared, right? And they want dx over dy, right? If they say dx over dy, then you know that you must first make sure that your equation is in the form of x equals to something in terms of y. So in this case, we have to first solve for x, then by applying the square root both sides. So it will be root of y is equals to x, but the root is plus or minus, so it's plus or minus. If I just use one of them, if maybe they say x must be greater than 0, so only consider the one for plus, then this is y exponent 1 over 2 is equals to x. So after making x the subject of the formula, we can now go and determine the x over what? Over dy. So that's very, very important. It must be x equals to something in terms of y. Then we derivate that equation using our power rule, 1 over 2 y, 1 over 2 minus 1, right? So it will be 1 over 2 y exponent minus 1 over 2. That will be our what? Our dx over dy. So they can trick you there, right? I'm just showing you because I've seen it, one of the past papers, they wanted something like this, right? So you must be able to interpret the meaning of the symbols for derivatives, right? Not just simply memorize, because a lot of you, if they say give you y equals to x squared and say determine dx over dy, you think they want dy over dx, right? And you just go and derivate knowing that, oh no, you actually made a mistake. So we must be very careful with the symbols that they can use there, right? But in this case, there's nothing tricky. They just give you dy over what? Over dx, the one that you are familiar with, the one that you've been engaging in the classroom with your teachers and getting the derivative, right? So it's dy over dx, meaning that our equation must simply be y equals to something in terms of x, meaning that we are going to derivate y in terms of what? Of x. Our answer must be really in terms of x, right? So our equation is already y equals to something in terms of x, so we can just simply derivate, right? Using the rules we've been learning. We know the power rule and the derivative of a constant is 0 and all that, right? So then the derivative will be simply 4 times 5, right? Which is going to be what? 20. Then we say x exponent 5 minus 1, then it will be exponent 4, right? So 4 times 6. So 4 times 6 is going to give us what? 24. So it will be minus 24. We go to the exponent and subtract 1. So that's the power rule, right? Then we know that here there's exponent 1. 3 times 1 is 3. We go to the exponent, we subtract 1 again. So it will be x exponent what? 1 minus 1, which will be x exponent 0. And anything exponent 0 is what? Is 1. So it will be 3 times 1, which is the same as what? As 3. So that is our answer for derivative. All right. So let's look at the last question from your question 9.2.2. They give you d of x. Remember it says determine, right? They give you d of x, dx, right, into that thing, right? So what does this symbol actually mean? It means we must get the derivative of this equation in terms of x, obviously, because they say dx. All right, so we must get the derivative, but be very careful when working with this notation. Once you write equals to, you are given as the answer of the what? Of the derivative. All right, so you must know that immediately once you write equals to, you must be derivating, because you'll be giving us the answer for the derivative. So be very careful when working with this symbol like this. So how do we actually get the derivative here? It is advisable that we first simplify inside our square brackets. Then once we feel it has been fully simplified, then we can write equals to show that now our answer is actually our what? Our derivative. All right, so what we'll do, we are going to simplify this. So when we simplify it, we'll just keep on writing dx because we are not getting the answer yet. We are just simplifying inside. So this is the same as what? Minus x exponent what? 1 over 3, right? over 2. All right, over 2, or rather I can write it clearly as 1, can just say minus 1 over 2, then x exponent 1 over 3, so that it can be easier to derivate. Okay, so let's go and simplify this part also. 1 exponent 2 is 1, 3x exponent to 3 squared is going to be 9x squared is going to be x squared, right? So we can further simplify it properly, right? When we further simplify it properly to be minus 1 over 2 x exponent 1 over 3 plus 1 over 9. This x squared is on the denominator, right? So if I take it to the numerator, we know that it will change on the exponent the sign to be minus 2, right? Because we know that if we have a over b, we can write it as a b exponent minus 1. So if I'm taking this up there, it will just change its exponent, right? So it's the same thing that we did with x squared, just take it on top and change the exponent. Now we have simplified it actually to something that can be derivatable, right? So in order to show that you are getting now the derivative, you write equal sign, right? So a lot of mistakes that a lot of students do is that you find them getting this question, they are writing equals to, and you are first simplifying, and it's very wrong, right? Simplify inside, and then when you write equals to, that's when you are now getting the what? The derivative. You are now derivating to show this is the answer for the derivative. So let's go and derivate it to be minus 1 over 2 times 1 over 3, right? X exponent 1 over 3 minus 1 plus 1 over 9 times minus 2, x exponent minus 2 minus what? Minus 1. We're just using the power rule. So that will be minus 1 over 6. X exponent, let's check here, 1 over 3 minus 1 is going to give us minus 2 over 3, minus 2 over 3. Then 1 over 9 times minus 2 is going to give us minus 2 over 9, right? So let me just confirm, yes, it's going to be minus 2 over 9. X minus 2 is going to be what? Minus 3. So that will be the answer for the what? For the derivative. Otherwise, that's all for me, grade 12. Thank you very much for joining us, and goodbye.